Hello everyone. The title of this video is Using the Distance Formula. Each example I'm going to be doing in this video is taken directly from a free online textbook at openstax.org, and I'm in their Algebra and Trigonometry text, section 2.1, titled The Rectangular Coordinate Systems and Graphs. And I'm working under the objective heading Using the Distance Formula. Now, each example I take from this book is either going to be from the examples in the reading or from the try it problems throughout the reading, or from some of the exercises, usually the even numbered ones, at the end of the section that are related to this particular objective. I will also have timestamps in the description of the video below for when each example begins in the video. I also request that whenever I start a new question, pause the video and try to work it out yourself first before, watching me doing it and comparing. Because if you're just watching me do these things and not practicing yourself, chances are you're not learning all that much. Alright, so let me go to my first example. All the examples I have written out on paper. Like I said, this objective is using the distance formula. And what we're asked to do is find the distance between the 2 points that are given on the xy coordinate plane, or the Cartesian plane, the rectangular coordinate system, whatever you want to call it. Alright, so first let me talk about this distance formula off to the side here. So before I even do example 1, let's talk about how do we find the distance between 2 points on the coordinate plane. So how about the distance between points? And say these points have coordinates x1, y1, right, for the first x coordinate and the first point's y coordinate. And say the other point I'm talking about has coordinates x2, comma, y2, right, for the x coordinate of the second point and the y coordinate of the second point. So here's the very rough sketch of the x-axis and y-axis, right, the xy plane. And suppose again we have these 2 points. Right? Now, one of the points could be here. Right? I'm just going to put the points in the first quadrant, in quadrant 1, but just understand that they could be anywhere. All right? These are generic coordinates here. So say this point here has an x coordinate, right, of x1, and the y coordinate of y1, right? That's the first point. And then I have another point. Again, it could be anywhere, but just to make things easier for our picture, I'm going to put this second point with x2, y2 over here. Right, so this has an x coordinate, right? The value on the x-axis it's over. Let's say that's x2. And a y coordinate, right? The value on the y-axis that it's in line with, that's y2. We're asked to find, the distance between these points, right? How far apart are they? So I'll draw a little segment, a line segment with these 2 points at the end. So this point, this segment right here. Right. And the length of this segment is the distance between the points, which I'll call, capital D for distance. Right. Now, imagine traveling from one of these points to the other. traveling from one of these points to the other. But you can only travel on the grid lines, if you had graph paper, right, which I would recommend, but you'd see some grid lines. Imagine I'm traveling from one point to the other, but I can only travel on the grid lines. I can only go right and left and up and down. Well, here's how you'd have to travel. You'd have to travel to the right this far. And I'm going to make a little 90-degree angle here because I'm turning left, and going up. You'd have to go up that far. And you see what has been created here is a right triangle. A right triangle. And these legs of the right triangle, right, these side lengths that form the 90-degree angle, have some pretty easy to calculate lengths. Right, the length of this side is just the change in the x coordinates. You take x2 minus x1 or x1 minus x2. And in some books you'll see this, they'll put absolute value symbols around this just to make it positive in case you accidentally took the small one minus the big one. Usually you take the large x coordinate minus the smaller one to get a positive value. Right. And then this length here, sorry, I put the word right triangle there. The length of this vertical leg is, y2 minus y1, right? This distance over here. And again, you'll see in some books they'll put absolute value symbols around that just to ensure that you have a positive number. But, so if we know these coordinates, if we know x1 and y1, and if we know what x2 and y2 are, we can find d, right? We can find the distance between them. Right? Since this is a right triangle, by the Pythagorean theorem, right? The Pythagorean theorem is something that only holds true for right triangles. The one leg squared, right? So x2 minus x1 squared, and notice I'm not putting absolute value symbols around them anymore, because when you square a real number, it ends up being positive anyway. So you got the change in the x coordinates between the endpoints squared, x2 minus x1 or x1 minus x2 squared, plus, the vertical leg squared, right? So y2 minus y1 squared should be equal to the length of the hypotenuse, right? That longest side, which is the distance between the points squared, right? So the horizontal leg squared plus the vertical leg squared equals the hypotenuse squared, or the distance between the points squared. And then taking the positive square root of both sides, right? I want the positive square root because this is a distance, right? We're not going to have negative distances. We get what's called the distance formula. And here it is, d, right, the distance between the two endpoints of that segment is the big, make a big square root. And then inside that square root, we have, the change in the x coordinates squared, x2 minus x1, or x1 minus x2. It doesn't really matter because you're squaring it afterwards. Plus, and then the change in the y coordinates squared, y2 minus y1, or y1 minus y2. Again, it doesn't matter because you're going to be squaring that quantity anyway. And again, all of that is inside the square root. Now I'll put this in a nice colorful box. Well, not really that colorful, it's just dark green. But there you go. This is what, the distance formula that's in the title of the video. Right. Okay, so when we're given 2 points and asked to find how far apart are they, how many units apart are they, you can do it in a couple ways. You can draw a picture. So like, for example, got 1, 4, and 11, 9 here. I can draw a rough picture of the xy coordinate plane, and let's say 1 is here on the x-axis and then the other x coordinate is 11. Alright, let's say that's over here. Just make sure that they're correct in the correct positions, right? 1 would be to the left of 11. And then for the y coordinates, right, you have y coordinates of 4 and 9, right? Let's say 4 is there, and 9 would be above that, right? Any larger numbers are higher on the y-axis. And I'll plot these points, right? So 1, 4, 1 on the x, 4 on the y, that's, this point here. And 11, 9, 11 on the x, 9 on the y, that's this point here. Okay, and then we're asked to find, this distance, right? What's this length? And again, I'll just call it d units for distance. Well, draw a little right triangle here. Go right that far, up that far, create a right angle. Can you see that this length would just be 11 minus 1, which is 10, right? This is 10 units apart, 10 units long. Then the vertical leg would be 9 minus 4, would be 5 units long, right? Went from 4 to 9, that's 5 units. And so d squared, right, by the Pythagorean theorem, since this is a right triangle, the hypotenuse squared would be the sum of the squares of the legs, right? It would be 10 squared plus 5 squared, which is 125, right? 100 plus 25. And so d is the square root of 125, and again, the positive square root. Now you can simplify this, right? I'm assuming you've seen how to simplify radicals before, right? This is the square root of 25 times the square root of 5, right? Using the product property for radicals. And that simplifies to 5 times the square root of 5 units. Right, that's how far apart those 2 points are on the coordinate plane. Now, if you leave it like this, right, they would call this the exact answer. Right, they would call this exact. That's where you leave it the way it is without putting it into a calculator and rounding. This would be called the exact answer. Right, these points are 5 times the square root of 5 units apart. Now, if you want to enter it into a calculator, and maybe they ask you to round to the nearest hundredth or something. Let me just pull up a calculator here. I got a TI-84 Plus emulator. So 5 times the square root of 5 is approximately 11.18. Right? So you could say that the distance between these 2 points is about 11 point. And it really depends on how many units they have you round it to, right? If they said round to the nearest tenth, it would be about 11.2. But I'm going to go to the nearest hundredth. So the distance between these 2 points is approximately 11.18 units. Right, let's clear that. Get that out of here. And this would be an approximate answer, right? I'll just put APPROX dot, right? An approximate versus an exact, right? And just pay attention if you're doing exercises in some homework or whatever, just pay attention to how they want it, right? Usually if they don't say anything, that means they want the exact answer, right, before you would punch it in a calculator. And if they want you to round it, then you're going to have to punch it in a calculator and round. Okay, so these 2 points, right, are a little more than 11 units apart, right? A little more than 11 units apart. Alright, so that's one way to do these things, right? Draw a nice little picture, use the Pythagorean theorem, or you can jump straight into the formula. Right? You don't have to draw a picture. So back to the points here, if I label these points, say this ordered pair 1, 4, call 1 x1 and 4 y1, and then the other ordered pair 11, 9, I call 11 x2 and 9 y2, and then just plug them into the formula. Right? So I could also do this. Right? I also have or using the formula. Right? The distance between these points, d, equals the square root, and just make a big square root. And then in the first set of parentheses in here, you have the change in the x-coordinates, 11 minus 1, that quantity, but then squared, right? Plus, and then in another set of parentheses, the change in the y-coordinates squared, right? 9 minus 4 squared. All right, so then you just simplify stuff, right? Parentheses first, 11 minus 1 is 10, so that's 10, then squared. 9 minus 4 is 5, right? And then you do powers, right? So this would be the square root of 100 plus 25, and then 100 plus 25 is 125. And this ends up being exactly the same thing as I had earlier with the picture, right? So these points, this, again, the square root of 125, just like I had earlier with the picture, right? 5 times the square root of 5, or as the exact distance between the points, or approximately 11.18 units apart, or 11.2 if you're going whatever decimal place you're rounding to. Just pay attention. Okay. So yeah, so I'm going to do both ways for the first few of these, and then I'll just finish the last few problems by just using the formula. Okay. So. And hopefully it was clear where the distance formula came from, right? The Pythagorean theorem, pretty much. So either you memorize the formula or learn how to draw pictures and remember, what the Pythagorean theorem states for right triangles. Okay, so next example. So again, another pair of points, 2, -5, and 7, 4. So again, I think you could draw a picture. Right, here's a small version of the xy plane. I'll mark off where the x-coordinates are. Right, the x-coordinates are 2 and 7. So 2 would be to the left of 7. So I'm not making pretty notches or anything like that. I'm just marking off where these numbers are in relation to one another on certain number lines, right? So the x-coordinates 2 and 7 are marked. Then -5 and +4, -5 on the y-axis would be below the origin, and +4 would be above the origin. And then I'll plot these points, 2, -5, 2 on the x, -5 on the y, that's this point here. And then 7, 4, 7 on the x, 4 on the y, that's this point here. And we're trying to find, this distance, right? The distance between them, the length of this segment. And again, I'll call it d units. And I make my little right triangle like this. I would go to the right and then up. Here's a right triangle right here. The length of this horizontal segment, right, I'm going from 2 to 7. That's 5 units, right? 7 minus 2. And then the vertical segment, go from -5 to +4. That's 5 units and 4 units. That's 9 units. Right, and you can do 4 minus -5, which would be 4 plus 5, right? Subtracting a negative is adding. That's 4 plus 5. That's 9 units. So by the Pythagorean theorem, right, d squared, the hypotenuse squared, would be equal to 5 squared plus 9 squared. That's 25 plus 81. That's 106. And then take the square root, right? So the distance between these points is the square root of 106 units, which is a little more than 10. And this doesn't break down, and this doesn't simplify any further because this is 2 times 53, and both of those are prime. All right, so there's no perfect square that goes into 106 evenly. So here we go. All right, and again, this would be considered an exact answer, right? Before you punch it in a calculator. These are the square root of 106 units apart. And if I want to round it, let's round it, might as well. Right? The square root of 106 is 10 point something. Let's go 10.30. Right, I'll do the nearest hundredth again. Right, I'll just stay consistent and do the nearest hundredth. So 10.30, 10.3. So the distance between these points is approximately 10.3, or 10.30 if you really want that 0 there. units. Right? There's again an approximate answer. And once again, I ask, just pay attention to how many decimal places they want you to round it to if they're asking you to round at all. All right, or you could use the formula. Right, the distance between these points is, and then make a big square root. And then in one set of parentheses under the square root, you have the change in the x coordinates. Right, I like to do second minus first, so 7 minus 2, and then square that. Right, plus, and then another set of parentheses, and inside this, you do the change in the y coordinates, 4 minus -5, and then square that. Well, that would be the square root of, 7 minus 2 is 5, and then you're going to square that. 4 minus -5 is 9, right? 4 plus 5, and then you're going to square that. And you see that this is exactly the same thing, right? It's 25 plus 81, exactly what I have over here. So we would end up with the square root of 106 units, or approximately 10.3 units apart these 2 points are. Okay, wonderful. I'm going to do this again. All right, now this one you're going to see is even easier, especially with a picture. See how these 2 points have the same y coordinate, right? If the 2 points you're looking at had the same x coordinate, or they had the same y coordinate like these, man, the distance between them is very, very simple, as you'll see here. Right, so I'm going to draw, again, a very small picture of the xy plane, and just mark off certain values on the x and y axis. Now the x coordinates are -4 and +10. Now -4 would be to the left of the origin, +10 would be over here to the right of the origin, right? Just make sure that they're in the correct places in relation to one another. And there's only one y coordinate, 3. Alright, so I'll plot these points, -4, 3, 10, 3. And you see this is just a horizontal segment. No right triangle, no triangle here. No triangle. So I don't even need the Pythagorean theorem. I just want to know how far apart these are. And that would simply be the distance from -4 to 10, which is 14 units. 10 minus -4. The distance between these 2 points is exactly 14 units. They are 14 units apart. And there's no need to punch that into a calculator, right? 14 is 14. Nothing doing. Alright. Now obviously on a picture it makes it easy, but as I've been saying, you can always use this formula. The distance between these 2 points, make a big square root. Then inside the first parentheses in here you have 10 minus -4, right? You subtract the x coordinates and then square that, right? 10 minus -4 squared, plus, and then inside your next set of parentheses, subtract the y coordinates, 3 minus 3, and then square that. Well, that's 0, right? That's nothing. We have the square root of 14 squared plus 0 squared. That would just be the square root of 196, which is just 14. I mean, the square root of 14 squared would just be 14. All right, so no matter how you do it, drawing a picture, using the formula, doesn't matter. You end up with the same distance either way. So you decide which one you like better. Right. By the way, the distance between these 2 points is 14 units. They are 14 units apart on the coordinate plane. Wonderful. Alright, so for the last page here, I'm just going to use the formula. Alright, again, you can draw pictures if you wish. But now that I have the formula down, I'm just going to jump right into it. So we have what's the distance between the points -3, 4 and 5, 2. Right, so again, the distance equals big square root. And then in the first set of parentheses, I'm putting subtracting the x coordinates, 5 minus -3. Right, don't forget minus and negative there. Right? That'll be 5 plus 3. and then don't forget to square that, right? Plus, and then in the next set of parentheses, right, squared, you're going to do subtract the y coordinates, 2 minus 4, or 4 minus 2, it doesn't matter. Right, just subtract the y coordinates. And we're getting the square root. 5 minus negative 3 is 5 plus 3, that's 8, so it's 8 squared, plus, and then 2 minus 4 is negative 2, but then you're going to square that, so it'll end up being positive anyway, right? 8 squared is 64. Negative 2 to the second is positive 4. So we end up with the square root of 68, which is the square root of 4 times the square root of 17, right? 4 times 17 is 68, and the square root of 4 is nice. So the distance between these is 2 times the square root of 17, units. And there's, again, the exact answer. Right, these 2 points are 2 times the square root of 17 units apart, which is going to be a little more than 8 that you're going to see, right? The square root of 68 would be a little more than 8 units, and let's see that. I'll punch this in a calculator, and just to stay consistent with my other questions here, I'll round to the nearest hundredth. Alright, so 2 times the square root of 17, and that's 8.25, approximately 8.25 units. Just putting in the rounding to the nearest hundredth, just to stay consistent with the other problems. All right, so these 2 points, if you were to put them on the coordinate plane, are just a little more, almost 8 1/4 units apart. Wonderful. And then my last example, this one's a real simple one, because one of the points is the origin, 0, 0, right? So really, we're just going to square this x coordinate and square that y coordinate, add them up, and then take the square root. We'll see, right? So the distance between them, d equals, again, big square root, and then in one set of parentheses, so now this one I'll do 5 minus 0, right? Just because 0 doesn't mean anything when I subtract, right? So subtract the x coordinates squared, plus, and then in the next set of parentheses, subtract the y coordinates, 2 minus 0 squared, and like I said, I end up with the square root of 5 squared plus 2 squared, right? 5 minus 0, 2 minus 0. It's just the x coordinate of the point that's not the origin squared, plus the y coordinate of the point that's not the origin squared. And this is the square root of 29. All right, that's 25 plus 4. So here's how many units apart. And that doesn't simplify any further, right? There are no perfect squares other than one that go into 29 evenly. And there you go. All right, so these 2 points, all right, this is the square root of 29 units away from the origin. And if you want to round this, right, this should be 5 point something. Let me punch this into a calculator. And I'll round to the nearest hundredth, just because that's what I've been doing with all the other problems. Square root of 29 is 5.385, so approximately 5.39 if I round to the nearest hundredth. Right. Sorry, I put so approximately 5.39. 5.39 units, and there's an approximate answer, but still, these 2 points are somewhere between 5 and 6 units apart on the coordinate plane. Great. Yeah. Very simple setup. Again, you can draw pictures of right triangles, pictures of segments. Use that stuff. Use the Pythagorean theorem if you got a right triangle involved. Or just jump straight to the formula. Take the square root of the change in the x coordinates squared plus the change in the y coordinates squared. Right? And then, of course, simplify that square root as much as possible. And if you're asked to round, right, just pay attention to how many decimal places you're asked to round to. Wonderful. All right, so I'm hoping that watching me go through these 5 questions here, 5 examples, help you in some way, when you're asked to use the distance formula, in 2 dimension on the coordinate plane on your own. and thank you very much for watching.